soundboard here, we're going to be covering the derivation for the final velocity when I don't have time equations. So to do that, we're going to be using the previous equation from the other video. And this is a little bit involved because we have to use the definition of time, which we can get for our equation sheet or solve for. And then we have to plug that into each of these. So this one has to go there, this one has to go there. So it's a little bit lengthy, but it's doable. So let's start. So VI, and I'll plug in that is VF minus VA over A. Plus 1/2 A VF minus VI A squared. Okay. So we'll bring that over here. So this is going to be VI VF. Just distribute to both terms. 1, then 2, so, minus VI times VI, which is VI squared. And that's going to be over A. So then we add to that. We have an 1/2 A, I'll put A up here. And this is going to be, and I'll write this out over here, VF minus VI, VF minus VI. And I got to FOIL this, so VF squared, then plus negative negative positive VI squared, then minus VF VI, and minus VF VI. So it's going to go VF to VF, VF to negative VI, then negative VI to VF, then negative VI to negative VI. And that's how we get all these. Okay? So if we write that in our equation, we're going to get VF squared plus VI squared minus 2 VF VI. And that's going to be over A squared, which we can cancel one of those with that. And then we have a 2A here, 2A here, and an A here, so we have to find a common denominator. So I'll put 2 there, then 2 up here, but I gotta put 2 over here, so I have to distribute this 2 through all of them. And once I do that, in that top part, I multiplied by 2 here, and I distributed that. I just didn't show that step, so I'll show that real quick. There. In case that was confusion there. Okay, once I do that, I'm going to get rid of this parentheses because I no longer need that. I have a common denominator. This term is going to cancel with that term. And this negative 2 VI squared plus VI squared, that's just a negative VI squared. So we're going to get delta x. Oh, make sure that's black. Make sure that's black. And delta x equals VF squared minus VI squared all over 2A. And here we can solve. This is our first equation. This is delta x, so we know that's true. That's on our sheet. If we want acceleration, we can multiply both sides by 2a and divide by delta x. So 2a divided by delta x. Oh, actually we leave the 2 there. Like so. We do that on both sides. We'll distribute that. We'll get a equals vf squared minus vi squared over 2 delta x. So there's our second one. And if we want to get our others, we can multiply this 2a to both sides. And then we can get rid of that on the bottom. Then we're going to have 2a delta x equals vf squared minus vi squared. And from here, we just have to choose which one we want. If we want vi squared, or we want vf squared, we have to add vi to both sides. Yeah, squared to both sides. Then we gotta take the square root if we want it. Just by velocity final. So there's another one. And if we want the other way around, we want vi squared, we can do that as well by adding vi to both sides, vi squared to both sides, and subtracting that whole thing as well. Something along those lines. And we'll get vi squared equals 2a delta x, looks like that's negative, plus vf squared. All right. Or it looks like we need to, yeah. So that's good. And that's all the equations.